Somewhere beneath our feet lies a world we almost never see. Layers of rock, coal, iron ore, copper, gold, minerals that have been buried for millions of years. And getting them out is not a job for an ordinary excavator. It takes machines that can tear through rock, load haul trucks in just a few passes, and keep working hour after hour in places where dust, heat, vibration, and exhaustion are part of the job. But here's the part most people miss. These machines are not built simply because bigger machines look impressive. They are built because the material underneath the mine is worth moving. So today, we're going from an old Caterpillar wheel loader that helped define heavy loading, all the way to a Chinese electric rope shovel weighing well over 1,000 tons. And along the way, we'll discover something surprising. The biggest machine isn't always the best one. Sometimes, it's the machine that gets the job done with the least wasted movement. And sometimes, getting bigger changes the entire mining operation. Let's start with a machine from an earlier generation, one that may look ordinary compared with what's coming. But watch it work, and you'll understand why it earned its reputation. Before today's ultra-large mining loaders became common, machines like the Caterpillar 992C were already doing something important, turning loose material into production. With around 690 horsepower and a standard bucket of roughly 12.6 cubic yards, the 992C was a serious loader for its time. But its real advantage wasn't just power, it was mobility. Unlike a giant crawler excavator locked to one loading face, the 992C could attack a pile, fill the bucket, reverse, move, and load again. That made it especially useful where material had to be moved quickly, including coal operations where high-volume buckets could carry large amounts of lighter material. But a bigger bucket doesn't automatically mean more production. Push too hard, and the loader can reach its limits before the bucket is even full. That's where the operator matters. A good operator isn't just filling the bucket. They're managing traction, positioning, cycle time, and the truck waiting beside them. Because in mining, productivity isn't always about having the most horsepower. Sometimes it's simply about wasting less time between one bucket and the next.
Calimera.
If the CAT 992C represents the old generation of heavy wheel loaders, the Komatsu WA1200-6 takes that idea to another level. With nearly 1,900 horsepower and an operating weight approaching 500,000 pounds, the WA1200-6 was built for high production loading. In hard rock applications, it typically uses buckets around 23.5 to 26 cubic yards, built to handle blasted rock, ore, and other heavy materials. But in coal operations, high-volume buckets can reach around 46 cubic yards or more, taking advantage of coal's lower density to move far more material with each cycle. That's where this loader really stands out. It can push into the pile, fill the bucket, reverse, reposition, and return to the truck with remarkable speed for a machine of this size. That makes it especially useful in large surface mines, where coal, overburden, and other materials may need to be moved across multiple loading areas. And just like the 992C, the operator makes a huge difference. Too much wheel spin wastes fuel and tires. Poor positioning adds seconds to every cycle. Do it right, and those seconds disappear. Because when a loader this large works hundreds of cycles, small movements can become big production numbers. But wheel loaders aren't always the answer. When the rock gets tougher and the loading face gets deeper, mines need a machine that can dig into the material instead of simply pushing into a pile. That's where the Komatsu PC2000-8 takes over. With about 976 horsepower and an operating weight of roughly 450,000 pounds, the PC2000-8 is built for serious mining work. Its bucket can hold around 16 to 18 cubic yards, depending on configuration. And unlike a wheel loader, it works from a fixed loading position, attacking the face one bucket at a time. At Finland's Kevitsa mine, PC2000-8 excavators have worked alongside Komatsu HD-785-7 haul trucks, rated to carry around 100 metric tons. The excavator digs. The haul truck takes the material away. And the entire operation depends on how quickly those two machines can work together. Watch an experienced operator, and the movement looks almost simple. The bucket cuts into the rock. The boom lifts. The house swings. The material drops into the truck. Then the bucket returns to the face. No wasted movement. No unnecessary swing. Just one cycle after another. And that's the real strength of a mining excavator like the PC2000-8. It doesn't need to be the biggest machine on the site. It needs to keep the trucks moving. But the next machine takes that same idea and pushes it into an even heavier class. At first glance, it may seem like simply a bigger version of the same idea. It isn't. The 6020B was designed specifically around the demands of surface mining, where the excavator has to spend its life digging hard material and loading trucks with predictable cycle times. Its standard backhoe bucket is 12 cubic meters, or about 15.7 cubic yards. Engine output is approximately 1,043 horsepower, and depending on configuration and operating conditions, the machine is around the 500,000-pound class. Now look closely at the bucket. It doesn't just scoop loose soil. The teeth are designed to enter broken rock and other heavy material, where every penetration of the face sends force through the entire attachment. The operator feels that work through the machine. Hydraulics load up. The structure flexes under force. The bucket fills. Then, the entire upper structure swings toward the waiting truck. Caterpillar designed the 6020B around three ideas that sound simple, but become extremely important on a 200-plus ton machine: safety, simplicity, and reliability. The design includes a centralized service area accessible from ground level, making routine maintenance less dependent on technicians climbing around the machine. And that tells us something about modern mining. Engineers are not only designing machines to dig harder, they're designing them around the people who have to keep them alive. Operators spend hours inside the cab. Technicians spend hours around the power module. Planners spend hours deciding where the machine should dig next. Every one of those people affects the final production number. The 6020B sits in an interesting position. It is big enough to handle serious mining work, but it isn't so large that the entire mine has to be redesigned around it. And that raises our first real question. When does making a mining machine bigger stop making it more efficient? We'll come back to that, because the next loader gives us a very different answer. By the time you reach the Liebherr R 9350, the scale changes. The Liebherr R 9350 entered the mining market in 2000. According to Liebherr, the model was initially developed and offered as the R994B before being renamed the R9350. Over the years, the platform has proven its reliability, productivity, and ability to handle demanding mining cycles at operations around the world. With 1,500 horsepower and an operating weight of around 666,000 pounds in backhoe configuration, the R9350 is already in another class. Its backhoe bucket can hold about 24.5 cubic yards at the specified material density. That's enough material to make the 6020B look noticeably smaller beside it. But the interesting part isn't simply the size. Liebherr designed the R9350 around fast cycles and high digging forces. And because the bucket is larger, every efficient cycle can move more material without simply increasing the number of cycles. The R9350 can also be configured as a backhoe or a face shovel, allowing mines to match the machine to different digging conditions. That's important because there is no single perfect way to attack a mine. Sometimes the material is below the machine. Sometimes the excavator needs to work directly into a high face. The attachment changes, the job changes. But the goal stays the same: keep material moving. And after millions of working hours in mines around the world, Liebherr says the R9350 platform has proven its reliability. So perhaps this is the answer to the question we just asked. A mining machine becomes worth making larger when the extra size can be converted into more productive cycles. But we're not done. The next Liebherr takes that idea far beyond the 300-ton class. The R996B is where the scale becomes difficult to comprehend. This machine was first introduced as the R996 in 1995 and evolved into the R996B in 2000. Liebherr's published specifications put the operating weight at approximately 1.48 million pounds with the backhoe attachment and about 1.49 million pounds with the shovel attachment. Power is around 3,000 horsepower, and depending on configuration, the bucket reaches roughly 47 cubic yards in backhoe configuration, with a shovel capacity around 44.5 cubic yards. Think about what that means. The bucket alone has enough volume to swallow several ordinary excavator buckets. The machine weighs hundreds of times more than a typical passenger vehicle. Yet underneath all that weight, the principle remains familiar. Diesel engines drive hydraulic pumps. High-pressure oil moves the cylinders. The boom and bucket attack the face. Then the upper structure swings toward the haul truck and dumps the load. Simple idea. Extraordinary scale. But at this size, small movements matter. The R996B is positioned carefully on a prepared bench, while haul trucks are placed to keep the swing angle as short as possible. A few wasted seconds may seem insignificant. Multiply them across thousands of cycles, and the lost production becomes enormous. That's why experienced operators can appear almost slow. They're not. They're removing every movement the machine doesn't need to make. And that may be why the R996B still has such a strong reputation among heavy equipment enthusiasts. Decades after its introduction, it remains one of those machines people remember. Not simply because it was big, because it made big mining look possible. But even at nearly 1.5 million pounds, the R996B isn't the end. The final machine on our list weighs more than twice as much. And beside it, even this legendary excavator starts to look surprisingly small. Now forget everything you've just seen. The TYHI WK-55 isn't simply a larger excavator. It's an electric rope shovel built for a completely different scale of mining. The first WK-55 was shipped to China's Pingshuo open-pit coal mine in 2008. At around 3.2 million pounds, with a 72 cubic yard bucket and roughly 4,850 kilowatts of installed power, it makes the R996B look almost small. But its real difference is underneath the surface. Electric motors, hoist ropes, and crowd mechanisms move the bucket into the material, lift it, swing it, and dump it into the haul truck. That simple rhythm is what makes rope shovels so effective in the world's largest open-pit mines. But a machine this large only works when everything around it is designed to match. The bench must support its weight. The haul fleet must keep up. The electrical system must keep it running. And operators, maintenance crews, and mine planners must keep every cycle productive. So is bigger always better? Not necessarily. The WK-55 only makes sense because the mine is big enough to justify it. And that brings us back to the real point of this journey. These machines aren't built simply because bigger machines look impressive. They're built because modern mines have to move extraordinary amounts of material to reach the resources beneath our feet. From the CAT 992C to the more than 3 million pound WK-55, the machines changed dramatically, but the purpose never did. Move more material, waste less time, keep the mine producing. That's what truly makes these machines powerful. Now I'm curious what you think. If you had to choose one machine to run a world's largest open-pit mine, would you take the Liebherr R996B or the TYHI WK-55? Tell me which one you would choose and why. And if you want to see more machines that push the limits of mining, subscribe to the channel. Because there are still machines out there that make everything we've seen today look small.